Hi, everyone, and welcome to the second installment where me and Sam are trying to dispel some of the biggest myths in quantitative risk analysis. In fact, it was Sam and Doug Hubbard who put together those myths for an article that they published on the Flow of Averages website, and we're going through one by one, trying to add a little bit more context to the issue and why it is nothing else but a perceived problem, not a real problem, and we've had a solution all along. So, Sam, over to you.
Yeah, great. So, well, what actually happened was, Doug and I are both combatants in the war on averages, and as we've gotten to know each other, we realized that we were hearing the same lame excuses from people for not quantifying uncertainty, and then I discovered that we were both telling the same lame jokes to represent these things, which will appear further on in this list. And so I thought, well, Doug, we need a top 10 list of lame excuses for not quantifying uncertainty. And we put that together a few years ago, and it actually appears in its entirety in my new book, Chancecalc. But at the Flow of Averages, flowofaverages.com website, it also appears up here. And just one little thing about Flow of Averages, the website, it's got a bunch of crazy stuff, including music left over from when I used to try to be a folk singer. It's got links to the Schmuzzle puzzle, which is something I invented when I discovered that I wasn't good enough to be a folk singer, and all that stuff. But let's dive into the Savage and Hubbard top 10 list of lame excuses for not quantifying uncertainty. And so you just click on the list here, and I'm going to blow this up a little bit here. So let's go down.
So this is what we've discussed last time, and you can find it on YouTube and on LinkedIn, the recording of our previous discussion on the number 10. We're just going down the list.
Yeah, so number 10 was our situation is too complex to model. So we do it in our head based on experience. And let's move on to the next one, because that one's already out there. Yep. But this one is excuse number 9. We don't have this specialized software to run simulations. And so just to read it, Sam says, that was a valid excuse before the data table function in Excel could do millions of calculations. This does for simulation what penicillin, based on moldy cantaloupe, did for antibiotics. And Doug says, Excel is specialized? So, Alex, there's a history here you probably do not know about. The data table function in Excel, in simple terms, vectorizes Excel. And I'm going to demonstrate that in a second. It's very important for people to see it. The data table function existed in Lotus 1, 2, 3. I really need to demonstrate it for you pretty quickly here.
Sure.
But I learned from Bill Sharp, Nobel laureate in economics, in about 1990, that the data table, and we were still using Lotus 1, 2, 3, that the data table could do Monte Carlo simulation. Well, I learned it from him. I thought, that's a great idea. And I tried it in Excel, and it crashed Excel mercilessly. And it was not until 2012 that I discovered that the data table would work in Excel, and probably had been working for a couple of years. There was a huge change in Excel when they went from 64,000 rows to 1 million rows in 2007. But the thing was so buggy back then, I didn't even bother trying it until Excel 2010. Okay, so let's make sure we understand what the data table is, because it implies that 1 billion people now have simulation.
Mm-hmm.
So let me just pop up Excel. And I'm going to explain the data table. It is something that, you know, maybe 1% of Excel users understand. And you don't have to understand it because it can be automated easily. And in the SIPmath tools from Probability Management, we do automate it. Okay, so what I'm going to look at here is I have I'm going to be a little abstract. I'm going to say I have a variable X and I have some formula, you know, f of X. And imagine, for example, that X, I'm going to say it's equal to 2, but X might be, for example, the world price of oil. And f of X might be the GDP of Brazil, right? Connected by hundreds and hundreds of formulas. So, but I'm going to do something much simpler. I'm going to say f of X is X squared. Let me center these to make it a little more attractive. Okay, f of X is X squared. And then the boss says, what I want is for you to try a bunch of what ifs. So I want you to return F for me if X equals 1, 2, 3, 4, 5. Okay, that's what I want. And only in this case, it's I want you to return the GDP of Brazil to me if oil is 70 a barrel, 80 barrel, 90 barrel, 100. And you say, well, wait a minute. Why don't you just make a model and copy the formulas down? No, your model of GDP of Brazil is like 500,000 formulas, right? And this is embedded right in the middle. No, it's impossible to copy the formulas. In the example I'm doing, you actually could copy the formulas. So this is what we do. So we go, okay, X equals 1. I put in a 1 here. And I copy this cell, Control C, and I go over to the F column and I say, edit, paste special values. 1. Okay. And then I put in a 2 here and I copy this and I say, I go over here. Oh, I'll do it this way. I'll do
that button.
Edit, paste special values. Are we having fun yet? No, we're not having fun. This is horrible and tedious. Okay. This is what the data table will do for you. So I'll delete that junk. And up here, and by the way, don't bother reading the documentation. So before YouTube, the only way to learn how to do this was to find someone else who knew how to do it and have them show you. Now you can go out on YouTube and figure out how to do it. But up here, I type equals that cell. Then I select that entire region. And then I go to data, what if analysis, data table, and I get this inscrutable little menu. I have no idea what it means. First thing it asks for is a row input cell. You don't even have a row input cell in this example, but you don't even know that. So the first thing it asks you for is something you don't know what it is, and you don't even have one. And so it's game over, right? I know that I have to move on to the column input cell. And what it should have said was, which cell in Excel should I repeatedly plug this column of data into while recalculating that cell? But they didn't have room to write that in a little menu, so they just wrote column input cell. So you have no idea what it means. But I know that we want to click in that cell. And I pull the trigger. Boom! Whoa! Look at this. Look at this. I got them all at once. Fantastic. Okay. What if I go in here and I say, it goes from x squared to x cubed. Boom, done.
Nice.
And then what Bill Sharp, bless his Nobel-winning heart, came up with. He is a very creative guy. He said, well, what would happen if I put equals rand in here? Oh my God. And you get a Monte Carlo here. Okay.
Wow.
That is, and then let me just go to a new sheet here. Let me close the, and by the way, don't ever use rand. Rand is terrible, but for many reasons, and in particular in SIT math, it's terrible. But what I'm going to do is demonstrate something with Chancecalc here. So I'm going to put equals rand in that cell. I think this is going to work. And then I'm going to go down here in Chancecalc, and I'm going to say, give me the average of rand. Oh, and what it just did was create another sheet with a data table on it, and run 1,000 trials of rand. So when I press the F9 key, 1,000, 1,000, 1,000, and it's giving me the average of rand there. And if I go to the settings in Chancecalc and say, give me 10,000 trials. Okay, let's try that with the F9 key. 10,000, 10,000, 10,000, 10,000. So this is the data table today. And, I could go to 100,000. It takes a while for it to set it up, but then let's see how long this takes. Okay. 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 Oh my God, it takes us. Well, we're busy guys. We can't wait around all afternoon for our Monte Carlo to run 100,000 trials. So that's the data table.
When I started doing risk analysis, a 10,000 trials would take us, and I'm not kidding, 24 hours.
It's crazy. Now, the other thing that's going on here, though, is that, let me go to probabilitymanagement.org. The other key is that the model, so the SITMath modeler tools, right, create models that do this with the data table. And so our big claim to fame here is that if you think about at-risk or crystal ball as being a tool, right? Like a saw and hammer is a tool. You build a birdhouse with a saw and hammer. And then the damn bird has to buy a saw and hammer to use the birdhouse, the simulation model, right? Not the SIP-math tools or Chancecalc, because we use the built-in data table so that the bird doesn't need to buy a saw and hammer. And that's a very important consideration. Furthermore, it's interactive. It's interactive. So yeah.
Exactly. Well, let me summarize this important, very important point. So first of all, one of the excuses are people using the software is too complex. We need specialized software. It's expensive. All of these three things are false because the Excel functionality has now expanded so much that you can basically use inherent inbuilt Excel functionality to do Monte Carlo simulations. However, you don't have to, because there are free or inexpensive additionals like add-ons to Excel that allow you to convert this manual work to clicking one or two buttons. So those excuses kind of go away because some of it is free. If it's not free, it is ridiculously inexpensive. Compared to millions and thousands and tens of thousands of what a banking risk management software would cost to do pretty much the same VAR calculations. That is just insanely inexpensive. And all it basically does, it automates the things that you could manually do. I mean, you can even code it in R or Python. And instead of doing it manually, you just click, kind of couple of buttons to do that for you. So it's an interface. So, it's a wonderful interface.
So the data, so anyone could go in there and do the data table. The SIP-math tools and Chancecalc from the nonprofit, right? We've got free versions and we have guilt-free versions where you pay us a little for the tool. But those tools create the data table for you and a couple of other things as well. But a couple other things go with this, because we've opened that Pandora's box. Number one, I think when this happened, probabilitymanagement.org already existed. We had done some work with Royal.Shell. We didn't have, because the data table didn't work. We're using some of Dan Feilestra's excellent software. The analytic solver suite, those are still fantastic tools in this environment, especially if you're doing optimization, which you can't do easily without that. But this is where my motto came from. None of my successes have been planned and none of my plans have been successful. This data table thing just fell in my lap. And so a corollary to none of my successes have been planned and none of my plans have been successful, I learned after I came up with that, and it was Louis Pasteur who said, chance favors the prepared mind. Okay, so the prepared mind, I was prepared because I've been doing this damn stuff. And oh my God, the data table does everything. And of course, Bill Sharp had taught me about the data table, so I was prepared there as well. But when it finally started to work, that's when the 501c3 nonprofit, probabilitymanagement.org, was able to go out and get funding. Oh my gosh, if the flaw of averages was a bacterial disease, then the data table is penicillin. All right. But wait, there's more. There is way more. The new dynamic array functions and the lambda functions in Excel are about to take this to a completely different level. Where you can easily do 1 million trials. Forget this puny 10,000 or even 100, So it's just wild, wild stuff. I need to close with one more thing here. Well, no, it's probably one of, you know what? I'm going to wait because it's probably one of the other excuses. But okay. I will say this. You got the hurdle. We don't have the specialized software. Okay. I know I'm going to put in a plug for this anyway. none of the specialized software. Okay, great. So I give you the Monte Carlo software. But the other problem is I wouldn't know how to generate the appropriate random inputs for it. That's a much bigger hurdle. Oh my God, I'm not a statistician. I don't know what the hell. Okay. So this is where a light bulb came on for me about 25 years ago. I was in my office at Stanford, and I flipped the switch in my office and the light bulb comes on. You know, that's not so remarkable, except I'd been thinking about this Monte Carlo problem. And what occurred to me at that instant was, oh my God, I don't know how to generate that electricity. I don't even know who generated it or where they generated it. I'm using it. How does that work? So I did a little research. There's a whole industry called power distribution, and they have specialized buildings called power plants with engineers in it that generate this stuff, and they send it out over the 60 cycle AC current, well, 50 cycle in Europe, okay? And then everybody else can use it. And it was at that point I said, oh my gosh, this was like 25 years ago.
Mm-hmm.
My goal is to create a new industry called distribution. And frankly, it took about 25 years. And this is the basis of what we call chancification today. And it's really...
And I think we're still getting there. But by the way, at the upcoming Risk Awareness Week in October this year, Sam will talk more, and maybe Sam will invite some other people to talk about chancification more, because I strongly believe that is the future. Some people need to generate the distributions, and everyone needs to use them. But not everyone has to know how to generate distributions.
Just like they don't know how to use how to generate electricity, but they know how to use it. And I'm really looking forward to Risk Awareness Week, and definitely we will be participating, hopefully with several folks signed up. So Alex, this is great. We're going to go on to
the issue number 8, which is my favorite one.
And always great to see you, Alex, and we will be in touch soon.
Thanks, Sam. Speak soon.
Bye-bye.
Bye.